This is Suruchi Parasha from B1's Lot of Tripoli, and I'm going to explain about the moving coil voltmeter today. Here we are with a scrap voltmeter, and I have opened it completely. So we have this outer plate with a scale on it to measure the drop potential. Then we have a mirror which we use to remove the parallax. And coming on to the main device of this voltmeter, this is the moving coil with a permanent magnet. So here I'm going to explain about the voltmeter. So we have a scrap voltmeter out here. Here we used to have a needle which moves back and forth depending upon the amount of voltage read through the probes. Well, what makes a needle to move back and forth? That's a kind of basic to know how voltmeter works. So let's see and figure out how the needle actually moves. I'm just showing you one of the old meters. So there was a needle. Well, this needle moves back and forth, and you see what's moving with the needle is there the tiny winding. There is actually a wire on the little copper looking like thing, and if you notice the dimple sort of silver part, this one, that is formed around it, and that goes almost all the way around it. That is a piece of iron. It's actually laminated, and when the power goes through that little winding, that's up in the center, and then it tries to align with the iron of that core around it. It actually turns that little thing, the little moment, into the magnet, and it starts trying to align up north and south so that it's going to move to try to line up well. There's a spring that works against in a very tiny little spring that keeps the needle hair back at the point where if the electricity is strong enough to overcome the spring and moves the needle up to wherever the measurement deals. So it's an analog type of meter, meaning it moves as far as the power has to move for, and so it's the electromagnet in the center and on some like watch bearing, and as power passes through those little windings then the needle will move up according to the strength of the signal, and it's getting through the windings. Now moving on to the construction of this permanent moving coil voltmeter. A coil of thin wire is mounted on an aluminum frame spindle positioned between the poles of a U-shaped magnet which is inside it. We can see here, and the coil around it. So these are made up of the magnetic alloys like alnico. The coil is pivoted on the jeweled bearing, and thus the coil is free to rotate. The current is fed to the coil through spiral springs which are free to rotate in numbers, and which are 2 in numbers. The coil, which carries a current which is to be measured, like moves in strong magnetic field produced by a permanent magnet, and the pointer is attached to the spindle like this, which shows the measured value on this scale. Now coming on to the working of this device, when a current flows through the coil, it generates a magnetic field which is proportional to the current in the case of ammeter and proportional to the voltage drop in case of potentiometer or voltmeter. The reflecting torque is produced by the electromagnetic action of the current in the coil and the magnetic field. When the torques are balanced, the moving coil will be stopped, and its angular deflection represents the amount of electric current or the potential drop measured against the fixed difference called a scale. We can see here a scale, so the potential drop is measured through it in volts. Now the controlling torque is provided by the 2 phosphorus bronze flat coiled helical springs. These springs serves as a flexible connection to the coiled conductors. Damping is caused by the eddy current set up in the aluminum coil, which prevents the oscillation of the coil. So that's the complete working and the construction models of the voltmeter. So that's it. Thank you.